Okay, so we're going to look at a few other things in terms of matrices. So let's look at this. We want to solve this three equations in three unknowns. Uh, x plus y plus z equals 0, 2x plus y plus 2z equals 2, x plus 2y plus 2z equals minus 1. So that's one thing we want to do. Let's suppose we also want to find the inverse. What is the inverse of this? Now, obviously, this has come straight from here, but let's suppose we want to find what the inverse of A is. Now, remember what the inverse of A is what that means is, remember that A times its inverse is going to give us 1, or in this case, because we're dealing with matrices, it's going to give us the identity matrix. So when we multiply these two things out, we can check our answer, and A times minus A is going to give us this, which is the identity matrix. So that's the other thing that we're going to try to do. And how we're going to do that is we're going to start with this, which again is just this system of equations, and we're going to have the identity matrix over here. And what we're going to try to do is, as we solve this for 1, 1, 1, answer, 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 this is going to turn into the inverse of A. Okay, so it looks complicated, and there's lots and lots of things that we have to do, but that's our starting point. X plus y plus z equals 0, and the rest. And we're just going to add the identity matrix over here. And we're going to try to solve this. We're going to get this side down to, back to the identity matrix. Okay, so the first thing, we don't touch the first row. We're going to look at the second row, and it is going to be R2 is going to become R2 minus 2R1. R2 minus 2R1. And there's lots of things happening here. So we're not touching the first row, so I'll just write that straight away. It's going to stay like that. Remember, our task here is to get 0 as our first task, is to get a couple of zeros here. So 2 times this minus 2 lots of that is 0. 1 minus 2 lots of that is going to be minus 1. This minus 2 lots of that is going to be 0. And this minus 2 is going to be 2. So it tells us something straight away about what y equals. And we do it over here as well. 0 minus 2 lots of this is minus 2. 1 minus 2 lots of that is 1. 0 minus 0. So some things have already changed. What are we going to do with this line? We've got to do a similar sort of thing. We're going to do, it's just R3 becomes R3 minus R1. R3 is such that it is just R3 minus R1. So 1 minus 1 is 0. 2 minus 1 is 1. 2 minus 1 is 1. Minus 1 minus 0 minus 1. This becomes minus 1. This is still 0. 1 minus 0 is 1. Okay, so as we get zeros here, we most likely get numbers here. Next thing we want to do is we want to get a 0 here. Now, I won't worry about changing that to a positive. You could do that, but let's look at what R3 is going to become. R3 is just R3 plus R2. R3 plus R2. So again, I'm not touching R1 or the top row. 1, 0, 0. Not touching it at all. Oops, that shouldn't be there. And I'm not touching the second row. 0, minus 1, 0, 2, minus 2, 1, 0. All I'm doing is operating on the third row. So the third row becomes row 3 plus row 2, which is 0. 1 plus minus 1, which is 0. 1 plus 0, 1. 1 plus minus 1 plus 2 is 1. Minus 1 minus another 2 is minus 3. 0 plus 1 1 plus 1. So again, as you can see, as we get zeros here, we're starting to get numbers here. And that's in a pretty good form. We could multiply this by -1. The next thing we want to do is get zeros here. We've already got a 0 here, so we really only have to operate on the top line. So let's get a 0 here first. So R1 becomes R1 minus R3. Okay, so now we didn't operate on the first and we operated on the last two, and we didn't operate on the 2, and now we're going back the other way. Most of the time we'll operate on these 2 and then 1. So let's look at what this is going to look like. R1 becomes R1 minus R3. 1 minus 0 is 1. 1 minus 0 is 1. This is why we're doing it. 1 minus 1 is 0, exactly what we want. 0 minus 1 is minus 1. 1 minus minus 3 is 4. 0 minus 1 is minus 1. 0 minus 1 is minus 1. So as you can see, as we get zeros on this side, we are losing zeros on the other. 0 minus 1, 0, 2, minus 2, 1, 0, 0, 0, 1, 1, minus 3, 1, 1. Okay, the only thing we need to get rid of is this one. So again, we're going to do R1 such that it's going to be R1 plus R2, because 1 plus minus 1 is going to give us our 0. Okay, 1 plus 0 is 1. That gives us our 0. 0 plus 1 is 0 plus 0 is 0. Minus 1 plus 2 is 1. R1 plus R2 is 2. 0 minus 1. And the rest don't change. So what we've got is and the bottom line becomes, so that's been very, very quick and very easy. The one thing that we would do, we don't want a minus there. How do we change this? Well, we could times this by minus 1. And we could write it out again, but I won't do that. This just becomes a plus 1. This obviously becomes a minus, a plus, and a minus. So what we get is we've got our solution. We can just read off our solution nice and quick, really easily. X equals 1, y equals minus 2, and z equals 1. And we could go back to our original equations that we had, sub them in to see if we were right. The other thing we can do is to see if this is the actual identity matrix. So I'm going to multiply this with this. So let's do that. So we want to multiply 1, 1, 1, 2, 1, 2, 1, 2, 2 with our solution to the other side, or what we believe it's going to be, and it's 2, 0, minus 1, 2, minus 1, 0, minus 3, 1, 1. Now, this is a rare occasion. Normally, these become fractions, the same denominator. This time it didn't. Now, if we're multiplying these, now remember, we use the across-down sort of method. Okay, so, and what we should get is 1, 0, 0, 0, 1, 0, etc., etc. So I'll write it out really big. We get 1 times 2 is 2. 1 times 2 is 2 plus 2. 1 times minus 3 is minus 3. So that's going to give us the 1, exactly what we want. The next line is going to be across here and down. So 1 times 0, 0. 1 times minus 1 is minus 1. And 1 times 1 is 1. And we're going to add them.